Today we're going to be applying properties of similar triangles. Artists use mathematical techniques to make two-dimensional paintings appear three-dimensional. The invention of perspective was based on the observation that faraway objects look smaller and closer than objects look larger. Mathematical theorems like the triangle proportionality theorem are important in making perspective drawing. Let's look at the triangle proportionality theorem. If a line is parallel to a side of the triangle, it intersects the other two sides, then it divides those two sides proportionally. So if EF is perpendicular to BC, then AE to EB is equal to AF to FC. Here we want to find the segment US. US is that top piece up in the corner, and it's given that ST is parallel to UV. So US to RU is equal to VT to RV by the triangle proportionality theorem. So if we substitute 14 for RU, 4 for VT, and 10 for RV, we can cross multiply to get 10 times US equals 56, and then divide both sides by 10 to get 5.6 or 5 3/5 for US. We also have a converse of the proportionality theorem that says that if they are proportional, then the two lines are parallel. So let's verify that DE is parallel to BC. We say AD to DB equals 10 over 15, which is 2/3, and AE to EC is 8 over 12, which is 2/3. Since they're equal, then DE is parallel to BC by the converse of the triangle proportionality theorem. Here's an example where we have AC, which is equal to 36 centimeters, and BC equal to 27 centimeters. DC is 20, as we can see in the picture, and EC is 15. And we want to verify that DE is parallel to AB. DC to AD is 20 to 16. We got the 16 by subtracting 20 from 36. And EC to BE is 15 to 12. And again, we got that from 27 minus 15. Since they're both equal to 5/4, then DE is parallel to AB by the converse of the triangle proportionality theorem. The two transversal proportionality says that if 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. So AC to CE is equal to BD to DF. An angle bisector of a triangle divides the opposite sides into two segments whose lengths are proportional to the lengths of the other two sides. So we have the triangle angle bisector theorem that says BD over DC is equal to AB over AC. So let's use the triangle angle bisector theorem to find PS and SR. PS to SR equals QP to QR. So we substitute in PS was x minus 2 and SR was x plus 5 from the picture, and QP is equal to 32, QR is equal to 40. Cross multiplying, we get 40 times x minus 2 equals 32 times x plus 5. Distributing, we get the following equation, and we can add 80 sides and subtract 32x from both sides, and then divide by 8 to get x equal to 30. Now we have to plug 30 in to find what PS is. So 30 minus 2 is 28, and then we plug in for SR to get 30 plus 5 is 35. So PS is equal to 28, SR is equal to 35. Here's some practice. Go ahead and take some time on these, see if you have any questions, and if you have any questions, we'll answer them in class tomorrow.